All right, hello everyone, let's get started. So today we'll be talking about an introduction to the Portworx CSI Driver. Specifically, we'll be talking about persistent container storage on Nomad and Kubernetes. So a little bit about myself before we get started. So I'm a software engineer at Portworx. Specifically, I work on the CSI control plane and I work a lot on the community. So I'm a contributor to Kubernetes CSI as well as Nomad CSI recently over the past year or so. For fun, I like climbing, running, and surfing. And as you can see, this is a picture of me in the background climbing in the French Alps a couple years ago. You can reach out to me on Twitter or on follow me on GitHub. So yeah, let's get started. So what we're going to cover today is a couple different things. First, we're going to go over Portworx architecture. Then we're going to go over CSI plugin installation. And then we're going to go over Nomad CSI with Portworx specifically, and then a quick demo, and then a comparison to Kubernetes CSI. So the first topic we're going to talk about today is Portworx architecture. So let's get started. So for the Portworx storage platform, it's basically a container native storage platform. So what does that mean? So we have a couple of different products, specifically PX Enterprise, that allows you to have container attached storage on Kubernetes and Nomad and some other container orchestrators as well. Next, we have something called PX Backup. This is a SaaS backup offering. Basically allows you to take backups of your GCP volumes or AWS or any CSI provider as well we support. And next is Portworx Data Services. This is a newer product that we're shipping. It's basically a database as a service for Kubernetes to kind of make that experience a little bit easier for Kubernetes users. So next we're going to talk about the CSI architecture with Portworx. So I covered both Nomad and Kubernetes in this slide just to kind of give a quick comparison on the two different deployment models. So on the left, we have Nomad. When you basically talk to Nomad, you're talking directly to the API, or you're going to be talking to the CLI, which in turn talks to the API. And this interacts with the Nomad controller, which then issues calls to the CSI driver, as well as issues calls to other things as well, like maybe Vault or other integrations. And from our CSI driver with Portworx, it'll communicate to the PX SDK server, and then it'll communicate with the PX storage layer as well, our underlying software-defined storage. And then for Kubernetes, it's a little bit different. So when you're using kubectl, you'll create objects. And for example, for those that are familiar with Kubernetes, you'll create a volume, and that change will get picked up first by the API server, which will take a record of it. And then the CSI sidecar will operate on that and issue calls to the CSI driver, as well as the kubelet will do things like mounting and publishing the volume for a pod. So this is what it looks like from a logical perspective. And then an actual physical deployment might look something like this. So if you have 3 worker nodes and a master node in a cluster, this is what it would look like. So it's the same logical kind of layout that I mentioned. You have the worker nodes all running. For Portworx, we have the PX CSI driver running on every node. We'll talk a little bit about that later. And then you have the SDK, the storage layer, and then all of these components as well working on the worker node. And then for the master node, you might have the Nomad client and then other Kubernetes control plane components as well, like the API server and the kube controller, for example. Cool. So next we're going to talk about CSI, or the container storage interface. And so what CSI is basically a generic interface for creating and managing storage. So this is a contract between 2 parties. It's the container orchestrators and then the storage plugins. And basically any storage plugin should work on any orchestrator, or that's kind of the goal of CSI. And then you have, with CSI, there's a gRPC library, and this is backed by protobuf. So you can actually go in and look at the CSI spec if you want. I'll include this link at the end and send it out. And it's basically broken up into 3 services. So there's the identity service. This has things like health, info, and other stuff as well. And then we have the controller service. This has things like create, delete, snapshot, etc. So, and then there's the node service as well, which has things like mount, unmount, and other things like that. And yeah, you can follow this link to basically go ahead and find the CSI spec. And so just like different schedulers have to implement the CSI spec, other CSI drivers need to implement the spec as well. So Portworx CSI Driver is an example of this. And we support up to CSI 1.4 and we'll support 1.5 soon as well. You can follow this link to find our exact CSI driver code. It interacts with our SDK server, like I mentioned, and then that in turn interacts with the PX container, which is proprietary. And so, like I mentioned before, we do a model where we deploy both the node and controller service together. So what this means basically is that some other CSI drivers might have a node CSI driver running on all the different nodes, and then it might have a controller container kind of working maybe on a different subset of nodes. However, for the Portworx CSI driver, we have them both running together on every node in the cluster. And the Portworx CSI driver supports both Nomad and Kubernetes. And later, when I'm talking about giving some examples on how to use it, I'll talk about all the different features that we support with the CSI driver. So just a little bit about adding Nomad CSI support. I implemented this support back in PX 2.8, which was July of 2021. It's actually very straightforward. I was very pleased to find out that it was very straightforward. I wasn't quite sure, adding a new container scheduler. In theory, it should work with, CSI should work with any container orchestrator, but, I figured there might be some quirks in between different container orchestrators. But I found out there was only one new API that we needed to add to our CSI driver, which is list snapshots. This is actually optional in Kubernetes because it actually keeps track of metadata for the user in a different object called the volume snapshot objects. So it's actually optional in Kubernetes. It's recommended, but optional. So we added it for PX 2.8. And for Nomad, it's actually required for Nomad volume snapshot list, because Nomad actually goes straight out to the CSI driver to get the list of snapshots in a cluster. And yeah, like I mentioned, there was only a few lines of code needed to add support for CSI on Nomad in our container, and nothing else. So it was a good developer experience adding Nomad CSI support. That's what I'm trying to say. Cool. So we've talked a little bit about the architecture. Now let's go ahead and talk about how you would actually install this on your Nomad cluster. So it's pretty straightforward with Nomad. There's a new if you're familiar with Nomad, there's the concept of jobs. This is similar to a deployment in Kubernetes. And so there's a new stanza that you'll want to add to your job, and you'll need to learn about. It's the CSI plugin stanza. So this stanza has an ID, a type, and a mount directory. So the ID is just the CSI driver's name. So this is what you'll refer to when you're creating a volume or deleting a snapshot, that kind of thing. So it's basically a way for Nomad to say, hey, only perform this operation for this driver. Next, you have the type, and that's basically the, there's a couple different types. There's controller, node, and monolith. For Portworx, like I mentioned, we do controller and node together, all on the same, on every node in the cluster. So for that, we have the monolith type as our CSI plugin type. Cool. And next is the mount directory. So this is basically where all of the mount paths will be created when you go ahead and create or try to mount a volume in the cluster. Cool. So there's a bunch of different CSI plugins on that support Nomad. So specifically, there's Ceph, Cinder, DigitalOcean, HostPath, and Kadolo at Portworx as well. And you can find all of these drivers in the HashiCorp Nomad repo itself under demo/CSI. I'm sure there's other drivers that support it. This is just all the ones that have it in the readily available in the demos section. Cool. Next, we're going to talk about Nomad Pack. This is a newer feature that was added in Nomad 1.2, I believe, or will be added soon. So it's similar to Helm, but for Nomad. It allows you to easily deploy applications to Nomad, kind of like a common area where you can kind of upload your examples and share your examples with the Nomad community. So let's say you're developing a database, you could have a Nomad pack for that to easily run it on Nomad. And just like CSI plugins are run in jobs, you could also have a Nomad pack for your CSI plugin. So Portworx will be adding a Nomad pack soon for our CSI driver so that you don't have to kind of copy and paste the job. You can go ahead and use Nomad pack to do that instead. So look forward to that in the future. But for now, let's talk about installing Portworx on CSI just through the job spec. So as I mentioned before, there's the CSI plugin stanza that you'll need to add to the Portworx deployment job. So we recommend naming it Portworx and having the type, definitely having the type as monolith. And then the map directory will be varlib osd CSI. And this gets mounted in our container, and this will get this will basically be where all of the CSI mount paths will be created when you try to mount a volume in a pod, or sorry, in a job. And full installation guide is available here at docs.portworx.com. Make sure to follow that if you're interested in using Portworx on Nomad. And really, it's straightforward. All you need to do is just apply a job, do Nomad job run with portworx.htl. Once you go to our docs, you'll find the example deployment. And yeah, that's all it takes to run Portworx CSI on Nomad. Cool. So now let's talk a little bit about the feature support that Portworx has on Nomad CSI. Yeah, like I mentioned before, Portworx 2.8 and later supports Nomad CSI. This means you can provision new volumes, register already existing volumes. So you could create a volume maybe through Pixie-Cuddle or another way, and then you could register that volume so that Nomad is aware that, hey, this volume object refers to this underlying Portworx volume. The same thing happens when you provision a new volume. It's just an easier way to kind of do that. Next, we have volumes cloning and snapshotting. So cloning is basically saying, hey, Nomad, I have this volume, but I'd like to create an exact copy of it. Will you do that? And this basically goes out to CSI create snapshot, sorry, CSI create volume, and it gives a reference to the old volume ID, and it'll create a copy for you. Next, there's snapshotting. So this is similar to cloning, but it's basically keeping a read-only copy of a volume, Portworx volume, to snapshot it for a time and place snapshot. Next, we have PX security. So PX security is our RBAC feature that uses JWT tokens to kind of authorize different Portworx SDK endpoints. So this is really for customers that are very security focused and they want to kind of protect their system, and maybe they have a multi-tenant system, you know, maybe an enterprise where there's a large Nomad cluster with many different teams using the same cluster. They don't want to kind of, they kind of want to isolate the permissions for different users. You could use PX security to basically enable you to do this. You can configure different users and different roles and kind of allow kind of fine-grained access control for your volume management. And next we have PX shared volumes. So this is basically using NFS under the covers, and it basically allows you to create a single volume and share that amongst multiple jobs or multiple instances of a job. So this is nice for things like applications that require a shared underlying volume. It's a good use case for that. And there's many other Portworx features that are supported with Nomad. Portworx itself has a whole suite of features. I'm not going to go into them in depth, but basically all of the Portworx specific features that are not specific to Kubernetes are available in Nomad. Cool. So let's talk about creating a CSI volume in Nomad. So first, you'll need to create a configuration file like the one below. So this here, there's an ID, a name, a type, which is CSI, plugin, the size, and then the capability. So As I mentioned, you'll want to have Portworx as the plugin ID for using our CSI driver, and then give it whatever name and size and capability that you want. And then to create a volume, all you need to do is do nomad volume create, and then the name for your configuration file. And the way this works in the backend system is that the Nomad CSI will actually reach out to Nomad through a REST API, put on volume ID create, and then Nomad will actually interact with the CSI driver through gRPC. So it'll call the CSI.createVolume call to any CSI driver, Portworx in this case, and then our Portworx CSI driver talks to our SDK layer over gRPC, and then that talks to PX storage. Similarly, you could actually create a volume straight through our PX SDK or through Pixie-Cuddle, and then you could register that volume in Nomad if you wish. So this allows for kind of customization of your deployment. If you want to create all the Portworx volumes ahead of time and then register them, that deployment model works as well. Next, we have shared volumes. So basically, it's the same flow as before, but there's a new capability that you'll be using. Access mode will be multi-node, multi-writer. So this basically tells the Portworx CSI driver, hey, this is a shared volume. And on our backend, what we'll do is we'll go ahead and create a shared v4 volume, which is a volume backed by NFS version 4 or greater. So yeah, that's kind of, and then the way it works in the backend architecture is the same. It's the same volume create, it's just different parameters passed in for creating. Cool, and then create snapshots. This is one of my favorite features of Nomad because of just how easy it is to really use. I work on Kubernetes snapshots, so I kind of am very experienced with how snapshots work in Kubernetes, and I was pretty happy with how Nomad snapshots work. So Nomad volume status, basically you can kind of check to see which volumes are in your cluster, and then you could do Nomad volume snapshot create, volume 1, snap 1. So this just basically says, hey, let's create a snapshot with volume 1 and then give that snap 1 the name. So this is very different from Kubernetes. Kubernetes, there's a volume snapshot object that you can use. This has a lot of benefits. I'll mention the benefits and differences between Kubernetes and Nomad later on, but it's just a very different, interesting kind of approach to snapshotting than Kubernetes had. Kubernetes had a lot more flags and a lot more kind of other ways you can kind of import snapshots as well. So maybe we'll see Nomad doing the same kind of model later on. But for now, it's Nomad volume snapshot creates volume and then snap 1. Cool. Restoring CSI snapshots is the next step. So snapshot's not useful unless you can also restore it. This is basically how you do it. You create a new volume, but just like before, the only difference is that you have to reference a snapshot ID. So in this case, the snapshot ID looks like this, Portworx volume ID. So I'll show an example of this later on in the demo, but this is basically how you kind of create or restore a snapshot and rehydrate it into a new volume. And again, this is a very similar flow as before, Nomad CLI to Nomad, so the CSI driver, and then down to our Portworx layer as well. Cool, and then yeah, after that, you would have a restored volume from a snapshot. Awesome, so that was a lot of slides. Let's go ahead and kind of show some actual code and show some actual configurations and usage of Nomad CSI with Portworx. So just a little bit about the demo today. It's going to be very straightforward. What we're going to do is create and use a volume. So we'll basically do a basic volume, and then we'll use that volume in a MySQL job. Then we'll go ahead and take a snapshot of our volume, and then we will restore that snapshot as a new volume, and then create a MySQL job with our new restored volume. Awesome. So let's go ahead and open up my CLI. Cool. So what we have here is a 4-node cluster. It's basically a Nomad cluster. So as you can see, we're on the latest version of Nomad that we support, which is Nomad 1.1.6. And then there's, you can go ahead and check the Nomad node status. So you can see it's a 4-node cluster. All nodes are ready and healthy. 4 nodes, awesome. And then what next we can do is we can check the Nomad CSI plugins that are currently running on this machine, on this cluster, sorry. So let's go ahead and do Nomad plugin status. Awesome. So there's the Portworx CSI drivers running, as you can see. There's the pxt.portworx.com. And then 3 controllers are healthy and 3 nodes are healthy. So this is basically, like I mentioned before, it's a monolith CSI driver, which means that 3 out of 3 and 3 out of 3, they're all running on our nodes. So Portworx is only running on 3 of the nodes in this cluster because that's the minimum required to have replication with our volumes. So that's why I have 3 Portworx nodes. You could have Portworx running on all 4 nodes, but for this demo, it's only 3 nodes. Awesome. So next, let's go ahead and do Nomad job status. I'll show you real quickly. We have the Portworx job is currently running. So if you do Portworx, Nomad job status Portworx, you'll see that all 3 Portworx instances, allocations are running correctly. Next, what we're going to have to do is I'm just going to delete some of the old jobs that we had running in this cluster. Server, and then let's also stop restore. We'll need that for later on in the demo, but just ignore that for now. Cool. And then let's do a Nomad volume status. As you can see, we already have a couple different volumes running in this cluster. So let's go ahead and clean that up. Let's just demo real quick how you would delete volumes, basically. Let's do Nomad volume delete. Nomad volume delete volume -1. Okay, so this volume's in use. So actually what we're going to have to do is do a Nomad volume deregister on this volume. So let's deregister these 2 guys. And awesome, now we have Nomad volume status. Nothing's running there. Let's go ahead and delete our last one as well. Vol restore, sorry. Cool, so there we go. We demoed how you might clean up your setup, just because I forgot to clean up beforehand, but that's fine. Nomad volume status. So now we have no volumes currently in our cluster. And then you could do Nomad job status, and you can see the only thing running in this cluster is Portworx. So we are ready to get started. So let's do, the first thing that we're going to want to do is create a volume. So let's go ahead and take a look at our demo file we have right here, basic.hcl. So this is a basic volume spec for creating a volume in Nomad. Just like the example that I mentioned earlier, the plugin ID is Portworx. It's a 1 GB volume of type CSI, and it is a single node writer volume. So this volume can basically be only used on a single node at a time. Awesome. So let's do Nomad volume create and do basic. Cool. So that created a new volume. So let's do, as you can see, that's the volume ID. Volume 1, and this is the name as well. So as you can see, we can do Nomad volume status. ID is volume 1, name is database like before. Plugin ID is Portworx. Awesome, all is good. Next, what we can actually do is use the pixyctl CLI. This is for interacting with Portworx, not Nomad. So you can do pixyctl volume list. And as you can see, it has our new database volume created here. Awesome. So let's go ahead and clean up some of the old volumes in this cluster real quick. Delete that. Delete this. And let's delete this. Actually, let's not delete that one. That's a snapshot. We'll clean that up later. Cool. So now, as you can see, our 1 volume was created here. It may have already existed, so let's go ahead and do a Nomad volume delete just to show you how that works. Or sorry, let's go to Nomad volume status. So we have our volume 1. Let's just go ahead and delete this. volume-1. Awesome, that went ahead and deleted it. And as you can see here, that successfully deleted it, like I mentioned before. Cool. So let's do pixie-cuddle volume list and nomad volume status. Cool. So we have no volumes running. Let's go ahead and create our volume again. Nomad volume create 1-basic.hcl. And then let's do a pixie-cuddle volume list. Boom, our new volume has been created. Awesome. So next, let's go and create a shared volume as well. So we have a new file here called shared.hdl, HCL. Let's go ahead and cat that. As you can see, the plugin ID is Portworx like before. The only difference really is that there's a multi-node, multi-writer capability. And this gets passed down to the CSI driver, and then the CSI driver, Portworx in this case, will be able to create a shared volume in our backend. And like I said, that's using NFS version 4 in the backend. Cool. So let's do nomad volume create on 2-shared. Cool. So there's a new volume that's been created. Let's go ahead and do nomad volume status. Awesome. So we have 2 volumes created, volume 1 and volume 2. And let's go ahead and look at pixie-cuddle volume list. Awesome. Database 2 has been created with shared v4. Perfect. Now let's go ahead and do a nomad. Let's go ahead and create a job, a MySQL job that's basically using our basic volume. So this is a big, not a big, but just takes up most of the tiny screen. Let's create a MySQL server job. So the main thing you need to note when you're creating a job using a CSI volume is that there's a volume section right here. And then the type will be CSI, and then access mode will be whichever access mode you want. This will be single node writer. And then the source is basically the volume that we've created already. Cool. So let's go ahead and do nomad job run MySQL. Sweet. So deployment is in progress. Deployment is running. So this will take a little bit to start up. What's basically happening is that Nomad has received the reference to create a new job, and this job references our CSI volume that we've created already. And so as you can see, deployment is running right now. So let's go ahead and do nomad job status. Cool. So we have MySQL server is now running. Before it was dead when it was stopped. And you could do MySQL server to see the full kind of view. So as you can see here, the latest version that we've ran is now running. Everything's running fine. Awesome. So let's go ahead. Yeah, so our MySQL container is running successfully with Nomad CSI Portworx volume. Cool. So the next thing that we'll want to do is demo volume snapshots. So let's do nomad volume snapshot list. So we already have one snapshot created. Let's go ahead and just clean up the setup and delete this volume snapshot. So as you see, you need the plugin ID, which is Portworx, and then the snapshot ID. Cool. So that deleted that. And now we have no snapshots. So now let's do nomad volume snapshot create. So this command takes 2 arguments, the volume ID and then a snapshot name. So let's do nomad volume snapshot create, and we'll have our volume-1. This is our basic volume that's being used by our MySQL job. And then let's just call it snap1 to make it easy. Awesome. So there we have a new snapshot created for our Nomad CSI volume. Next, what we'll go ahead and do is we'll actually want to restore this volume now that we've kind of taken a snapshot. Let's go ahead and show what it might look like to restore the volume. So as I mentioned before, it's the same as creating a normal volume. The only thing that's different is there's a reference to a snapshot ID. Perfect. So let's go ahead and do nomad volume create /volume restore. Oops, I forgot to do one thing. Basically, the reason that that failed right there is that I haven't updated volume restore with our snapshot ID. So let's do nomad volume snapshot list. And we need to take this snapshot ID and use it for our restore. So we're just going to open up the restore volume configuration and just add in our new snapshot ID that's been created. Perfect. So now if we run that again, awesome. So there we go. I created a new volume based on the snapshot that we've already created. Perfect. So then now let's do nomad volume status. There we go. We have a new volume created. And just to show you what it looks like in PixieCuddle, there is a snapshot added right here. So as you can see, it's snap1 that's created, just like we mentioned before. Perfect. Lastly, what we'll go ahead and do is we'll create a new job that kind of uses this new restored volume. So if you do nomad job, let's cat the restore job. And as you can see, it has a reference to our vol-restore. Let's do nomad job run 5 restore job. Perfect. So deployment is running. So everything's working just fine. If you do nomad job status, you'll see we have a new MySQL server restored and it's running. So awesome. So that's kind of the end of the demo. It just shows you a couple different things. Basically, we're showing you how you can kind of go ahead and restore, create and use a volume, a basic volume, how you can use a volume in a MySQL job, create a snapshot of that volume, and then restore the snapshot and use it in a new job, just like you would before. Awesome. So that was the demo. Next, lastly, we're gonna talk about a comparison with Kubernetes. Awesome. So the first thing we're gonna talk about is just from an end user's perspective. I am a plugin maintainer, but I'm also an end user at the end of the day. As I test our implementation of CSI, I kind of get an idea of what it's like to kind of use both container orchestrators. So from a client experience, the first thing I noticed is how quick everything was with Nomad. When you do Nomad volume create, it synchronously reaches out to CSI and immediately performs a volume create command. This is a little different from Kubernetes, where you have a kind of a controller-based state of the world. Both have their pros and cons. You know, with under high load with a huge Nomad cluster, synchronous API might take a little while to kind of return, whereas a controller-based, you kind of have that asynchronous volume creation. Next is first is the client experience. What I noticed is that with Nomad, it feels like you're a direct consumer of the CSI spec, which I liked as a plugin maintainer. You're actually using the exact kind of names for the CSI volume kind of access modes. And then with Kubernetes, you're kind of using the abstractions for better or for worse. So the PVCs, for example, if you're familiar with Kubernetes and volume snapshot. So that's just a little difference that I noticed. And lastly, the configuration is very different between Kubernetes and Nomad. From what I noticed, the Nomad configurations were a little bit more straightforward. It was a very simple CLI, and some of the commands didn't even need a configuration file, which I liked. So like volume snapshot, for example, didn't require a config, which is very nice. And then Kubernetes just has a little bit more was needed to install, for example, installing CRDs and learning a little bit more about config files. Both models have their pros and cons, of course, but just some differences that I noted. And next, we have the plugin maintainers perspective. So the people that create CSI drivers and manage them. So the first thing I noticed is the deployment is pretty straightforward with Nomad. All you really have is the CSI plugin stanza, and maybe add a couple of different volume mounts, a couple of different configurations to your job, and then boom, you're pretty much running a Nomad CSI plugin. With Kubernetes, there's Kubernetes has been a project for a little bit longer, so it has a little bit more features. CSI kind of decided to have a sidecars model for that. So the plugin maintainer is responsible for not only starting their plugin, but also the sidecars, managing the CRDs for the user, and then as well as the RBAC for any RBAC updates that come out. The next thing that I noticed is for contributing Nomad, it was, again, it was pretty straightforward. With a mono repo, I knew that there was only one place to really look for code changes, because one of the things that we did as part of adding support for Nomad CSI with Portworx was I had to fix a couple bugs in Nomad to kind of get our PX security feature working. So I sent some PRs, and it was pretty straightforward contribution experience for that. And for Kubernetes, it's broken up into microservices. So pros and cons, again, it can be a little hard to navigate, but it's nice that once you are familiar with the landscape, you know that any changes related to snapshotting will be in the snapshotting repo, for example. Lastly, I noticed with Kubernetes, there's community update meetings. You can kind of attend to kind of see what's going on in that space. They're broken up into SIGs, special interest groups, and so SIG storage in Kubernetes is the group that kind of handles CSI for Kubernetes. And Nomad, from what I saw, that didn't have the kind of community sync meetings that Kubernetes had. So just a little difference. Yeah, and that's the talk. So just a little overview of what we talked about today. We went in depth into a Portworx architecture. We talked about how to install CSI plugins, as well as how to use Nomad CSI with Portworx. We did a quick demo on how to create volumes and use them, and snapshots and all that fun stuff. And then we did a comparison with Kubernetes, just for anyone kind of out there that is using Kubernetes or using Nomad and kind of wanted to get an idea of what might be the difference between CSI for Kubernetes and for Nomad. And yeah, that's it. Thanks everyone for joining. Let me know if you have any questions or comments. I'll be answering questions in the chat, but as well as over Twitter. If you have any questions, feel free to send me a message. And yeah, that's it. Thanks everyone.